I've got a small screen. Okay. Which is hard to read.
Oh.
So honestly, trust me. Go sit on the front row and turn around.
I just had to click got it. Good afternoon, everyone, and welcome to today's seminar hosted by the Global Childhoods Research Hub. I would like to acknowledge the Wurundjeri people of the Kulin Nation on whose country we live and work. I pay my respects to their elders, past and present, and to the deep knowledges embedded within First Nations communities and their ongoing connection of and care for Sky Country, the waterways, and the land. And I'd like to just notify you in the room that we are recording this session today. It is my great pleasure to introduce today's speaker, Professor Bill Cope from the University of Illinois at Urbana-Champaign. Now, I could give you the standard academic introduction and list his many achievements, which are substantial, but that would take up all of his speaking time. And frankly, I've known Bill long enough to know he'd prefer I didn't do that.
Good work.
Bill is a longtime colleague and an even longer friend. We go back over 20 years, which means I've had the rare pleasure of watching a brilliant mind stay consistently ahead of the curve while most of us are still trying to find the Wi-Fi password. He is one of the most thoughtful and incisive voices in the field of literacy and digital learning, someone who just doesn't theorize change, but builds it. His work with Mary Kalantzis has reimagined what learning can be in a world increasingly mediated by technology. And now, as we all grapple with the rise of generative AI, Bill and Mary and their graduate students are once again asking the questions that matter. Not just what can AI do, but what should it do and for whom? And just when you think you've got a handle on his scope, you discover he's also authored Jesus, the Complete Works, a meticulously researched reconstruction of every known text about Jesus, including many that were banned, buried, or edited out by the early church. Turns out Jesus was not just a spiritual figure, but a pretty fierce critic of wealth, power, and patriarchy. Who knew? This is classic Bill, fearless, rigorous, and always ahead of the curve. Today, he'll take us into the world of generative AI and its implications for education. Not just the panic about cheating, but the deeper question, how can AI extend rather than erode meaningful learning? Please join me in welcoming a truly original thinker, Professor Bill Cope.
Oh, well, thank you, Nicola. I don't know whether I would have preferred you to read my CV because, you know, I have these other lives that I keep kind of vaguely separate, but that's okay. That's okay. Thank you for that very kind words, Nicola. So it's funny to be back here. I lived in Melbourne for 8 years, and it's and I haven't been here back for 10 years now, actually. So this is I left 2006. Yeah. Haven't been back. Only been back once since then. So it's nice to be back here. And yeah, Nicola was saying this generative AI stuff. It's funny, people know that we've been doing digital technology stuff, but also we're kind of interested in philosophy of language and semiotics, philosophy of meaning. So we've got a kind of a philosophical interest as well. And strangely, this stuff has landed on our lap as incredibly interesting. And we have a very unusual take on it, by the way. If you want to know what's happening in generative AI, there's only one place to go, and you go and look at what's happened today at Archive, right? That's where it's all happening. So interestingly, Archive, which is the Cornell repository, and interestingly, Archive is global. 50% of AI is Chinese, which is also all publishing at Archive, Cornell University, not in China, all publishing in English. And if you want to go there, it's incredibly interesting. But it doesn't say what I'm going to say, which is eccentric, unusual. I'm coming at it from a kind of a language point of view, but we've spent a lot of time thinking about it, and I don't think we're wrong, but you can tell us if you think we're wrong. So I'm going to try to do 3 things in this talk, and I'm going to apologize up front in that I put together this kind of, I'm sorry, I've got to stand behind this black box, which is not like I normally like wandering around, but because this is being recorded, I'll get rid of the recording. I've got to stand here because they're using my audio and, and my camera. So I'm sorry about that. What I'm going to apologize for is it's actually kind of 3 talks and about 15 minutes each. So it'll be a while. I'm sorry. And I'm going to probably overload you. I sat with Nicola now and said, Nicola, should I delete this and this and this? And she says, no, leave it in there. So I'm going to apologize for that. I wouldn't normally do this much in the one talk, but I'll do it anyhow. There are 3 parts. This is enormously disruptive. And I've got to say, I've worked in this area for a long time now, digital, multi-literacy, digital media and whatever. And something happened in one article in 2017 and 200 lines of software code, right? And it was, nobody saw it coming. And it's spectacularly interesting from a linguistic point of view and enormously disruptive from an education point of view. So I'm going to try and give you a sense of how it might be that in general terms and try to explain my peculiar take on it, which you won't see in archive, right? We read archive, we have a rough sense of what's happening there, but what I'm going to say to you is kind of an educational semiotic semantic take on what it means, not what it does, what it means. Second thing is, we've been very lucky. One of the things about the US, here I used to get ARC grants, which was, 150,000 for this. We have got many millions of dollars worth of grants. That's one of the things about the US, which has probably just ended the day before yesterday, but it doesn't matter. We've had the opportunity to build things and do things, which tragically we wouldn't have had here, to be quite frank. So I'm going to show you some software we've built, which uses generative AI in a learning environment. And I'm going to show you, and as a matter of fact, we launched the version I'm going to show you in my class of 75 students at 4 o'clock this morning. So I've been up since 3:30 this morning because I had a class beginning in this space this morning. So I'm going to show you that space and show you the work that my students are doing there. The third thing is I'm going to talk about implications, and at the risk of a spoiler and where we're going, that's where I'm going to say artificial intelligence is a terrible idea, right? And I'm going to explain an alternative idea as a way to understand what's happening here. So that's in order to try and keep you awake by part 3. Hopefully you'll still be here. So let me go here now. I'll put that in there, and the arrow should work. Okay, so firstly, I'm going to call it AI all the way through until the end, where I'm going to say that's a terrible idea. Let's rethink it. So firstly, it's everywhere. And one of the key things about AI, it's not just ChatGPT, it's software environments which are constantly learning from their users. So one of the things for education that makes this exciting, interesting, threatening in all sorts of ways is these are learning machines. So everything you do a Google search, it learns more about you. You use Gmail, it learns more about you. It's about building profiles, and these are learning systems. I'm going to talk in a moment about the kind of technologies of learning that are behind them. So it's an immediate problem for education, because if we've got a machine that can think and think for us, what are we going to do? Well, the answer is, if anything other than a select response test that's highly proctored, you can't know whether it's the machine or the student answering. And in fact, there are these AI detectors, supposedly, none of which are reliable. False positives, you can end up accusing people unjustly, or people who do really good work. There are all sorts of disasters about it. But the good news is, by the way, as soon as these detectors are there are these other software services for $6.99 a month where you can use things which defeat any detector, and it's generative AI which is defeating it. Now, there's an English scholar of e-learning by the name of Mike Sharples, and he calls this democratizing cheating, right? And his estimate is that in the US, 12 to 15% of US essays submitted were written in paper mills. In other words, you pay $100 to somebody in India or wherever, and they write it for you. Well, this is just cheaper. It's the same thing. So it's not as if this is a new phenomenon. It's a historic phenomenon that's been around for a while. But down at the bottom there, I've got the next slide is a definitive solution. Are you ready for the definitive solution? This is the definitive solution. Now, the truth is, this is also not a joke, because this is what we're doing in education. This is what we win highly proctored tests. We don't trust students with AI. But for me, this is not a joke in the sense that what's the implicit theory of learning behind this activity? This is the implicit theory of learning. Learning is only long-term memory. That's the theory of learning over, right? And it's highly individualized. You can't talk to your neighbors. You can't look things up. And is that a very good model for knowledge when I can't remember people's phone numbers anymore? I used to remember everybody's phone number. But look, we have these cognitive prostheses with this all the time, which allow us to remember. So, you know, a doctor is walking around their rounds and they've got an iPad and they can look things up and they've got information systems. We're submerged in this world of these things that we call cognitive prostheses. So this was always a bad idea. It's even worse now. So that's the immediate solution, but I'm going to now give a more complicated solution to this problem. But before I do that, what I want to say again in this first part, explaining it, is I think this is, in world historical terms, a really huge moment, actually. I'm not a, also it's a terrible moment, by the way. It's a terrible moment for anybody who's looking for jobs. Already in the US, graduate unemployment is higher than the national average now, and it's trending very, very quickly. You know, Microsoft laid off 7,000 people, and Amazon's about to do it. Salesforce is laying off huge numbers of people because a lot of things which are in the realm of cognitive work, software, all sorts of stuff, is now done by the AI. Software is devastated by this, by the way. Software, you just don't need, you only need very high level people who can work with the AI now. So anyhow, this was a world historical moment. It's either 1452, but if you've got a bigger version of things, 1039 was the invention of movable type. So what we have in education is profoundly based on this invention, right? Everything we do, which is texts and libraries and readings and references, are all based on that, that invention. This is big because it's the first time that it's not just the reproduction of text. This is the production of text, a completely coherent, meaningful text that's never been seen before. And what's interesting is that both generative AI and humans are able, and machines for the first time, are able to make coherent meaning from the endless combinatorial possibilities of language. This is for us very, very interesting. And the first machine to do it. Now, what we've got is, you know, those infinities of recombination of meaning. And you know, the last 300 words I said have never been said before, right? In that particular order, in this particular way. So we're recombining it. Everything's iterative, everything's recreated in the world. Well, here's now a machine that can recreate the world as well. Now, what's interesting is the mechanism is entirely different. And I think that's, in a practical and philosophical way, sense, very, very important. And the power of the AI is how different it is from humans and how it does things that humans could never do. What's also important and interesting, and we've just written a longer paper about this, which is not quite ready, it's nearly finished, is that this new AI is utterly different from the two preceding waves. In fact, what we've had in the history of AI is three incomparably different paradigms. It's a kind of it's a long story. This paper up on the top there that I've cited, Mary and I did this history of Plato, which was the world's first computer-mediated learning system. Really, it was symbolic and rule-based AI that drove that. Then what it was replaced by is data-driven AI, which is big data, and you might have heard about supervised and unsupervised machine learning. That paradigm's gone as well. It's not gone, it's still used in some places for some things, but what text semantic AI does is utterly different as a technology. And as I say, that article there initiates, it was initially just 200 lines of code, which created this transformer architecture, and they're the 8 people who did it at Google. Now, one of the kind of philosophical issues here is this just parroting. So there's a new book out now, Emily Bender, you might have seen her. She's become quite a prominent spokesperson. She's just published a book about this. She calls these things stochastic parrots. Chomsky was entirely dismissive. It's been covered up at the top, but it's a New York Times article. Interestingly, though, it's based on the idea that what you do is you have a bag of words. Every word that's been published, you might have heard that phrase. Interestingly, down on the right, it was Chomsky's supervisor who invented that phrase. And what Chomsky's supervisor said, and so people use this bag of words, it's just undifferentiated words which have all been processed via these statistical methods. What Zelig Harris says in this key 1954 article, is that the sentence is, language is not just a pack of words. So the most important thing for me is how the system regards it as a bag of words, but it's not just that. And how is it not just that? So that's what I'll try to explain. So this is our theory, which people might know from multiliteracy's work quite well. So our argument vis-a-vis literacy was that it's not about reproducing meaning, like teach the kids how to spelling and grammar and, you know, how to write proper, that kind of stuff, and they'll write proper. Well, you know, in fact, what we have with meaning is always a transformational process where the world gets rewritten in ways it was never written before. You have found designs, which might be, sentences, but sentences of all kinds and a lot of diversity. But when we reconstruct them, we do design work and the world's never the same. Now, what's interesting about this AI is that it does the same thing. So what it does, it takes meaningful stuff in. The word we use, and we've published this 2-volume grammar with Cambridge University Press a couple of years ago, where we talk about this idea of transposition, which is we're all the time moving things from one form of meaning to another. What this specifically does, it takes meaningful stuff in, which is words, for example, and it uses binary notation to name things. It uses base 2 calculation to add things up, and it uses Boolean logic for if-then, you know, just binaries. Just all that is binaries based on zeros and ones. So all you can do with any form of computing is this transpositional process through binary notation. Now, how does that work in generative AI? Well, you might have heard this idea of tokens. Here's my Bill definition of a token, you know, a semantic definition of a token. So when we write, and look, this is a writing technology. What's, again, really, really interesting, and yes, you can create images, that's another whole story, but you need writing to prompt and you need labeled images for that to work. Let's just focus on writing. What we have is things that are graphemes, and this works because, you know, silently behind everything we do is this universal scripting system called Unicode. There is only one scripting system in the world, and it's how you're able to talk across machines, across languages. And there are 150-odd thousand characters in Unicode. Keeps getting updated all the time, but that includes emojis. It includes, obviously, the alphabet, Chinese characters, every graphic symbol that's ever been used in every human language, including linear A and linear B, which no one can translate yet. So anyhow, what happens is generative AI doesn't work at that level. It does work at that level with ideographs. So within Unicode, you know, 8 is an ideograph. Ideographs are representations of ideas. It doesn't deal with phonemes, but what it does, it clusters phonemes into tokens. Now, the most important thing that I want to argue is these tokens are semantic units, right? That's what they are. And in this definition of text, by the way, software code is text. And math is text, because it uses Unicode as the way of operating. Okay, now how does it work? So what happens is it has no notion of meaning, right? But what there is in there is what we would call a latent semantics. So here's a sentence. I walk to work. And what we do is the tokenization process, this sentence is 5 tokens, right? Because we broke walk into walk and ed, and walk is you know, the verb to walk, and then ed indicates past tense. So that's 5 tokens. Now I'm going to, and these are these generative AI pictures which I created. So I walk to work. Now, how is this a different type of walking, right? So I have a standard poodle who I walk every day, and he doesn't look like that. He looks straggly and whatever, but he's a very nice dog. So, and that doesn't look like me, does it? And you know, anyhow, I walk. We live in a forest, so I walk through the forest. Doesn't look like it. It doesn't matter. Generative AI did it. So I walk the dog. Now, the fact is, this is a very different type of walk to that. That's very A to B, direction oriented, blah, blah, blah. So what's interesting is that this is not the same walk. This is a different kind of walk. And this is a different type of walk again. Looks like the same word. And what we did in grammar, when we did grammar with kids in schools, walked is the past tense of walk. But in fact, what we have grammatically happening in our minds and our lives is we have a lot of different types of walked, which we mark with transitivity, case, voice, mood, a whole lot of things, which if you're a fanatical linguist, you'd be able to name, but we have them in our minds as a matter of practice. And we know those are different types of walk because of that intrinsic meaning structures that we have in our mind. Now, what are these meaning structures? Ironically, Chomsky, who doesn't like Well, Chomsky's lots of problems with Chomsky, but ironically, Chomsky's right. So what happens is we have, the tree structures in Chomsky. There's a noun and there's a verb, and you put the things together. They're a set of semantic primitives. What Chomsky does is deny anything semantic. He says it's just syntactic. But in fact, nouns are things. Kids know this, and verbs are actions, right? So we have a set of semantic primitives, but in our everyday practice, we know about those different types of walks. We have a grammar that we can't state, which is in our minds, which is how we order an infinitely complex world and keep rebuilding it. You might know that we're we use the Halliday system and we've rebuilt it in a whole lot of ways. It's a long story, but again, I love this line of Halliday's that grammar is a theory of human experience. So in other words, what we want to do is think about what do we do with language, which is actually a theory of human experience, which is how we build meaning in the world. Now, this is a dense slide, which I'm not going to go through in any great detail. But what I'm going to say is these are the big differences. These things both rebuild meaning in a way that's never been built before, coherent meaning, but they do it in entirely different ways. So what happens is, like with the generative AI work, they took 5 billion words, which is every published word. Let's say that's the number roughly. And what they did is they built the relationship of every word to every other word. A little bit less than that, actually. The transformer architecture is you take this word here, right, and you look at a series of preceding words because that defines what the kind of walk. There are 10,000 types of walk in here defined by the words behind that. And when you hear about weights and vectors, they're the numbers that represent 10,000 different types of walk. So when you say there are 10 billion parameters in here or trillion parameters, that's what it means. Now, no human being can deal with that amount of data, but this is raw zeros and ones empirical data. What we have in our minds is a way of grammatically ordering the world, which the effect is the same, but the mechanisms are different. But also what it means is that the AI is unbelievably powerful. I can't have read everything, let alone know the relationship of words to each other in everything that's ever written. It does. But it's also very limited. It can't do things because it has no semantic basis for what it's doing. So the argument that we're getting to here is these things are deeply different. And you might be hearing me say artificial is a terrible idea later on. They're deeply different. And what's powerful is the differences. And how do we use those differences? That's the first part. Sorry, that was too much and there's too much to come. Do we want to ask a couple of questions or just keep on going? Okay. I'm getting hot. I got to take my sweater off. It was cold this morning, so I came with a sweater and things. Okay, so look, you folks we actually started building this in Melbourne. In fact, we've built 3 versions of this thing over the last 20 odd years. And we're now building an entirely new version of this, which I'm going to show you, this platform called Scholar. When we came to build, so we've been working with the generative AI in the Scholar space since the beginning of 23. So that's about 2.5 years. So we've got quite a lot of experience doing it now, but we decided we had to start again because it's so profoundly different. So I'm going to give you a walkthrough of this new space that we call CyberScholar to show you how it might work in an educational context with a real educational example. What I want to do is I want to just tell you, foreshadow with you what you're going to see. So while the students do their work, we have a thing called Cyber Helper, not AI, and I'm going to explain the cyber thing more in part 3, where we've got AI with you all the time, helping you think and helping you write. And then we have Cyber Reviewer, which once you've got your ideas together, we can deal with your ideas in a big picture sense. Now, what's the sites for this? The answer is everywhere. I'm going to show you an example of one of our doctoral students working in this space, but we've done it with, from grade 4 up, we've done it in high schools. We've done it with medical students doing patient notes. We've done it with police trainees doing police reports. So any form of writing which involves what we call complex epistemic performance. Answering B to question 2 is not complex epistemic performance. That's just remembering some darn thing, right? So what we want to do is any site where you've got to build a complex knowledge representation. And in grade 4, that means writing a good animals project. So anyhow, that's the kind of context. So what I'm going to do is I'm going to escape now and go onto the web. So let me just go over here. I didn't mean to open that up. I opened that by mistake. So let me go back here. This is the kind of the login page. we're in Illinois, you see. That's the cornfields that are all around. And this is the homepage. So let me say this. What we have is, well, you've got to think of this as kind of a version of Google Docs or a version of Microsoft Word. That's really what it is. And I'm going to go into here. Now, these other things, what a student will see is works and projects, right? This is something where you can build these, you can run a class in here, and we have these things called rubric agents. We're going to explain to you in a second how they work. And SuperAN is only, admin is only for people who are managing all the accounts, which is us. So I'm going to go into works. And what I'm going to do is I'm going to take an existing work by one of our students. And here I'm going to take this one here, which is one of our doctoral students. Now, I might size that up a little bit so you can, that's why I said, come down the front if you want to come over here. If you can't see it, just come and sit. There's chairs over here, because this is not a PowerPoint slide. So we have an editor here. And what I'm going to do is I'm going to just scroll through. Let me get an earlier version of it where I know I've got, is that going to let me scroll? Where's my mouse? Did I go? Yes. Oh, no. Where did I leave mine? Oh, I'm not a big one for trackpads. So let me, sorry, I might have to size that down a bit because this is the complexities. Let me scroll down here. Sorry, that's not scroll. Yes. Yeah, sorry. Trackpad. As a matter of fact, what I might do is that it's possible even that I opened this up half an hour ago. Let me just refresh that screen and go back to, oh, look. Oh, I've been logged out. That's what it was since I opened. So I'll go back to here. So, right. So this is, I just want to show you what this particular student was doing. And this is this idea of knowledge representations, complex epistemic performance, and all that kind of stuff. Why is it not letting me scroll down? There we go. There we go. There we go. I'll go back to a version which is a view only version where you can see what it is the student's done. So what she's doing is she's writing about station rotation and generative AI in a middle school. So, you know, station rotation is all around the room. You've got kids doing different things, but they're talking to AI when they go to each station. So what she's written is this kind of complex knowledge representation here, which includes theoretical concepts in the background. Let me see if I can make that a bit bigger for you. What is station rotation? I just want to show you the extent of what's there. She's put in a YouTube video, what's generative AI, differentiated adaptive learning, using state rotation, generative AI, constructivism, active learning, differentiated instruction applications in the middle school, AI in the classroom. This is some stuff from Google, stuff about Khan-Migo, there's Sal Khan, Magic AI, critics and limitations. So this is like a conventional kind of academic essay that she's been writing, and we get down the end and there's a pile of references. Now, remember I said there were two phases. There's a helper phase, which is while you're writing, and then I've got a complete work here, but then there's the review phase. Let's go to the helper phase. And look, the quick thing across here, this is CyberHelper. There's a whole lot of tools you've got here anyhow, which can support you while you're doing stuff. But I'm going to show you this one particularly, which is CyberHelper. And what I need to do is I will then go to the working version. So we're keeping lots and lots of version. Doesn't look like me having sized that up so big. So let me go here. Let me go to the, well, I'll go to the working version like so. You see there's a regular toolbar there. So let's say there's something here that I want to talk to you about. So common struggle of the thingo. Let me say something comes up. I'll be exploring the integration of station rotation. Let's say some of the stuff I'm talking about here, I want to think about it more. So what I'm going to do is I'm going to select that, and I'm going to go up here and I'm going to select this CyberHelper, which is there. And here are a number of things which the person can do, right? They can brainstorm, they can research, they can plan, they can expand, they can summarize if I've just written too much and I want it to be a sentence. Expand is if I've help me write more, translate any language you want to name, check the argument flow, advise, proofread. These are all things that are called meta prompts that we've written into the back of the system. So what they can do is they can do that. But what I want to also show you is, I don't know, I'm having trouble here with this damn thing. Okay, so what I'm going to do is let me brainstorm something. So let's we'll go back to that. I'll select that paragraph again because I want to kind of brainstorm the ideas that I've put in this paragraph. Could be a one word, could be the whole work. You just, you want help with something. So I'm going to go over here to Cyber Helper, and I'm going to brainstorm. And what it will do is, now let me show you another thing here about configuration. And this is down the back end, but it's kind of important so you understand technically what's happening. What a teacher would normally do is a teacher would configure this for the student, but these are doctoral students, so we let them do it. Firstly, we are not tethered to any foundation model. So in here we've got OpenAI, Llama. Llama is Meta, as in Facebook. DeepSeek is the Chinese one, as you know. Grok is Elon Musk. Quen is Alibaba. Anthropic, Google. Mistral is the French one. So there are only 7 of these damn things, and we've got them all in there in various models. So you're able to operate with any model. We're not tethered to any particular model in the whole thing. But the other thing which is really important is we have a thing called a knowledge base. So this one here, which is called the CyberScholar knowledge repository, class repository, is everything our doctoral and master's students have written for the last 5 years and everything that Mary and I have written. It's 35 million words, which is 32 million. It's 35 million tokens, about 32 million words in there. So, we've kept everything they've done and we've got it all digitized and we put it all in there. So what's going to be doing this? Again, I'm starting to get to the artificial intelligence idea. Nothing artificial about this. This is the collective intelligence of our students and us, which will be helping you brainstorm this idea. Okay. But the other thing we're going to do is we have these things called rubric agents, right? So yeah, it's the normal rubric you have, except what's unusual about, and you've heard about agents in AI, what's unusual about rubric agents, and look, here we've got one for medical patient notes, we've got one for writing a police report. This one is the one we use for ourselves, which is based on learning by design. And if I go back here and I look at it further, this is us using the multiliteracies theory. But what we've done for each of the criteria, previous experience, experiencing the known, experiencing the new, we've written these rather long because the AI responds very well if you're hyper explicit about things. So, and by the way, we've got a rubric making tool in here. So if you're the teacher doing grade 4 animals, you can build a grade 4 animals rubric. But this is the one we use for our students. And you can see here, it's relatively elaborate. So this is, there are 3 bits of this configuration. One is the underlying foundation model. I won't do DeepSeek. I'll do, that's pretty good, GPT-4o latest, and the Scholar repo. And I can actually decide how narrowly or broadly focused that's going to be. So what I'm going to do now is when I go down to, I'll close up the configuration. Down here, this is the boilerplate thing. Hey, I'm ready to do this for you. And I can add something to it, look for specifically for something. So I'm going to do this now. And now when I do that, hopefully, is it running? Oh, no, run without user input. No, I've actually done, it's telling me I haven't written something to modify the generic prompt. So I run it without user input, sorry. And it's talking to me, it knows my name. Please help me brainstorm, So it's taken the generic prompt and it's doing it, and it's generating ideas. Now, what's kind of staggering to us is that what this is doing, it's dealing with our 35 million tokens. It's looking at the whole of this work, which is a 5,000 word work, and it's looking at that rather elaborate set of evaluation criteria. And here's a course, Dr. Gobe. So what happens is it knows me. This is all these AIs, they all know you. It's about the system learning you. I put a profile in and it's used that. So it knows me. So essential ideas. So what it's done, it's suggesting a set of ideas, closely related ideas, critical perspectives. Look at that. There's a little problem that's calling everything one. And then these are some suggestions it's got about what I might do. So what's wrong with the public AIs is they will say, oh, would you like me to write this essay for you? So we've actually put in meta prompts which don't do that. They say, do not write it for the student, but suggest lines of thought for them to do something. And what it's about pushing their thinking even further rather than doing the work for you. Now, the problem with the public AIs is they are simply designed to do the work for you. They're hyper friendly. You know, would you like me to, whatever. So what we've done is we've built this in this particular way. So let me say now that we've finished the work, we've worked on this, and now it comes to the review phase. So I'm going to go over here now. I've got all my ideas together. Now I want big picture ideas and big picture feedback on what I've written about station rotation and generative AI. What it does is I'm going to do a new review. And what it does, it increments it so we can see the way in which this review has influenced your thinking. So this is all about tracking. Look, this is a surveillance system. It's about tracking everything you do, seeing how you're using AI, how much AI you're using in relation to your own work. So we go over here and we do a new review. It can be a self-review, can be a cyber review, or it can be you doing a peer review of someone else's work. So what we do is we always have humans operating off the same rubric, giving human feedback to moderate the AI feedback. So I'm going to go here to cyber review. And now it's looking at the whole thing. So we've got this rubric. We're operating with OpenAI latest for the foundation model. We've got the 35 million tokens, and we're going to start generating the review. Again, what it does, it creates a new version. And again, what's staggering for us is we're just surprised. The amount of computation going on here is just, I mean, we're kind of shocked by it, to be quite frank. So because we're at the end, the southern, somewhere down near Antarctica, this is going slower than normal. So, and this server is in, if you want to know where the server is, it's in Ohio. So
everything's slow in the southern.
Yeah. And also it's because my theory about the southern hemisphere is because the water goes down the plugs the opposite way. So that really slows things down. So anyhow, it's going through it now. And what's interesting here is these are kind of high level things that it's looking at. Unfortunately, I won't be able to show it to you until it's gone through all 10. So these things are things we call rubric agents. So each one of these is an agent. So the first one's an experiential agent. The third one is a conceptual agent. The fourth one's a theoretical agent, a critical agent, an agent. So these are kind of, and the reason why we have adopted the word agent, which they're using everywhere anyhow, is these are kind of, if you like, epistemic personas that are working over your work, right? Each of them is a kind of a set of perspectives about your work that's being created. You had a nice phrase, Fazil, about epistemic. What was your phrase about? I often use that. I'm sorry, I'm trying to think of it now. Virtues. Epistemic virtues. So these are 10 agents with peculiar epistemic virtues. That's a really nice way to think of it, to be quite frank. So it's working over the work. And again, just the scale of this is kind of mind-boggling to us, to be quite frank. And it takes 30 seconds. Well, you know, what's this now? Might be a minute by the time we're finished because the water goes down the plug the other way. I'm doing not too badly with time because I think I can get through the last section quickly because this is nearly done now. So this is the reviewer phase, but I want to show you what the result is. And there we go. It's done. Last one, working on the last one now. But, you know, if it's the animals project, the teacher might have created a rubric about the environment, about, you know, lifestyle, or life cycle or whatever. So I'll scroll down here now. And what's interesting is, again, it's addressing me personally, gets to know me over time and what my interests are. And let me break down this according to the key dimensions. So this gives you feedback which is just over the top in terms of its specificity. Suggestions for improvement include more critical self-reflection on the motivation assumption of technology, describe specific formative experiences in greater detail, explicitly discuss. Very, very, you know, we're not going to give you the answer, but we're going to force you to think more about what you're doing. This is the empirical side. And if I scroll down to here, it's going to say overall evaluation, whatever. This is now the conceptual work, the concept you've used. So let's say I come down to this and it says personalized learning. It's, you know, have you mentioned personalized learning? Well, what I'm going to do down here is when I get to the bottom of that, I'm going to say here, you know, I don't quite know what you mean by personalized learning. Okay, so off we go. And what it's doing, it's actually substantially using the resource we've given it. So, you know, the idea is the animals teacher in grade 4 gives it a whole pile of animal books and environmental books and whatever, and it'll give back good results. So here it is, key dimensions of personalized learning, blah, 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 blah. And see here, it cites Cope and Colantz's 2019, because in fact, we put that in the repository. So what it's doing, it's speaking to the material. We had a lovely example, by the way, where kids in a high school were doing a democracy essay, and the teacher put in a 2,000 page encyclopedia of democracy around the world. So in other words, the kids couldn't have read all of that, but the machines read all of that. And the teacher has designed the rubric agents and designed the knowledge base in such a way that the teacher's in control, but also talking to all 30 students at the same time. So down here, but what do I get at the end? Oh my goodness, that's a pile of words. And I'm going to say here, please, before I read the whole thing, is please summarize in 30 words. Right, and here's a 30-word summary. Before I to digest it, there's a 30-word summary of that there. And then if I go down here into theory, all sorts of concrete references about theory. Look at this, universal design for learning, conclusions, this is strong, and a whole lot of things. Warm regards, rubric agent. That's cute. I like that. This is stuff that it does itself, by the way. You set the whole framework up and it starts talking like this. But look, I'm just back from, we're doing some really exciting work with small languages in India. And I'm going to say, I'm not a first language speaker of English. My native language is Oriya. How many people have heard of Oriya? Nobody? You have? Okay. Please explain in Oriya. Now, I'll explain about Oriya in a second. Well, I type it in, and I've spelled that wrongly. There's no G. Oriya is a language of a dish estate with probably 10 million speakers, but not a big resource base, not a big internet published resource base, and also has a really beautiful, really strange font, which you're going to see in a second. And what's unbelievably interesting, there it is in Oriya. Let me pull this over so we can have more space for it. What's interesting is this is thought through this problem about the theory of whatever in Oriya. It's not a translation. It's thought through again, even though there are no resources in Oriya to do it. So one of the crazy things, and this is our argument about semantics, on arXiv, you're just going to see technical stuff about all the numbers. But what's interesting is it would not be possible to do this unless it had a set of latent semantic understandings in German, in Chinese. If they're multilingual, they go, the corpus, it goes really, really well like this. So what we're interested in is I've got a person there that we're working with who's coming to spend time with us on a Fulbright, who has a small language called Kuvi, which has 150,000 speakers and no corpus. And we're going to try and use this with kids in schools there and she's actually built the scripting system for this language. It didn't have a scripting system. So this is kind of, for us, kind of slightly mind-blowing. Okay, so I'm going to jump out of that and do the conclusions now. So so let me just see. I'm showing my whole screen, aren't I? So I'll go back to here, and this is the end. Sorry, as I say, it really was 3 talks. So this is the workflow that you saw happening there. We've got analytics in there. So what we're doing is we're tracking everything that goes on, every keystroke, every timestamp, so we can see what's the AI and what's you. And we can see if you've worked very hard with the AI. And by the way, I think we're going to fail you if you don't use AI, right? AI is now so helpful and so important. If you're not working with AI, you're not doing the work. So what we'll do is in this system, we're going to set thresholds, minimum 20%, maximum this. You can set your own, teacher can set their threshold. And what we're doing is we're capturing everything with keystrokes, timestamps, click streams, all those things along the way. And if I go back to this, the generative AI is the thinking stuff. The contextual AI tracks exactly what you're doing. Okay, analytics. What I'm not going to say now, because these were the slides I debated on deleting with Nicola. I'll just tell you what was in them. And I'm sorry, this has got too many words. It comes from a paper we've recently written. Select response testing has to go. Sorry, Barry, because it can only, on item response theory, most select response can't do any of these things effectively. The problem with supply response assessments, classical essays, is all of these problems about iterator reliability, practicality, consequential validity, sample size. I mean, there's a whole lot of deep problems with that, which natural language processing never solved. So the second generation of AI dealt with automated writing assessment, but now there is no excuse to do anything other than what we would call what we call kind of deep learning, complex epistemic performance as documented in these spaces. So that's a quick summary of what we're talking about. And this argument here is why the LLMs in the wild, which is going to ChatGPT and doing stuff, is disastrous for a set of reasons. The prompts, who's designing the prompts? It's a generic database as opposed to a specialized one. It has no rubric agents which have direct you to educational criteria. So this is a framework as to why those things are an absolute disaster, and why we in education have to build something like CyberScholar, or why we built something like CyberScholar. Okay, now my conclusions, which I'm going to do in 5 minutes. People talk about artificial general intelligence, artificial superintelligence. It's all rubbish. And it's rubbish for this reason. This was the Manchester one. And right at the very start, Turing was blown away by the fact that he was able to find prime numbers that no human could reasonably find. These things have always been much, much smarter than humans. Superintelligence, if you want to call it that, when it comes to prime numbers. When it comes to dealing with 5 billion words and 6 trillion vectors, they're much smarter than humans, but it's just utterly different from humans. So what we want to do, and by the way, the artificial intelligence idea was invented by John McCarthy. There he is. It was a very clever catch title to get funding for a seminar back in 1955. And that's his definition, which we think is really problematic. We are operating on a different paradigm, and there's a paper we've written here, which is referenced down the bottom, where we did a historical thing about the rise of cybernetics. There's Norbert Wiener, the original kind of inventor of the idea. And the idea is there's the Kybernetes in Greek is the oarsman at the back of the boat. So you adjust this way, it's about feedback systems. It's not about the oar doing the job. It's about a human relationship and a feedback system. So we kind of like this idea, a little bit of arcane history here. What's the first intelligent machine? Well, in our definition, this is the first intelligent machine. Watt's double-acting steam engine of 1754. And I love this here. Oh, I can't walk away from here. I love this thing here. That thing's called the governor. So when it spins out, less steam goes back in, more steam. And that machine had been programmed with 2 commands, less and more. Right. So and the cybernetics people call this a non-trivial machine. A shovel is a trivial machine. I press the shovel into the ground, it digs. A word processor is a trivial machine. I type the letter A and it comes up on the screen. What we're interested in is non-trivial machines. And this is our definition then of what's artificial about it, which is any human machine, for instance, meaning that can be delegated to a machine and undertake to undertake something semi-autonomously. This then is our model of, the cyber, which is machines that have done a whole lot of stuff. And what's interesting is we want to call this collective intelligence, not artificial intelligence, because when the LLM does this, there are 5 points in which humans are absolutely in control. Firstly, the corpus. Everybody who's published everything in the human existence, published material only, is there. So that's human. And what happens is the machine has learned it through self-supervised learning and pre-training. I can explain how that kind of works, but it's the machine has just gone through and processed the relationship between the words. Secondly, fine-tuning, which is called, again, it's a wonderful, wonderful return to behaviorism. It's called reinforcement learning with human feedback. So when the machine answers my question, which is what's the most effective way for me to suicide, or I'm a terrorist and what's the most effective way to make a dirty bomb, the machine could give that answer and won't give it because it's been told, naughty machine, don't answer that question, right? So it's classic behaviorism and it's literally called reinforcement learning, this process. The meta prompt also is when the machine gives you the answer to the essay, it's because the meta prompt in the system, which is sometimes people hack the system and they show the meta prompts. They're just fascinating. It says, talk like this, talk like that, say something else, try and be helpful, never be critical. So the meta prompts are absolutely fascinating. And what we have to do in education is undo those meta prompts because they're not critical. I'll agree with you about everything. Fourthly, there's the user prompt. Nothing happens until somebody puts a prompt in. And the fifth thing is this latest technologies now, which is reasoning. You put a prompt in, and what it is, it deconstructs your prompt into a series of steps. And some of the AIs show you those steps. DeepSeek does, and Grok does. The Musk one does. The other ones hide it because they don't want to let out their trade secrets. But reasoning is there as well. So what we're trying to do with CyberScholar is build. We've got meta prompts. We have reasoning models, and we do all sorts of stuff that try to tune it to education. Hey, that's the end. Sorry, too long. We've set this thing up if people are interested. And that QR code will take you to stuff that we've written recently.
We've got like a few minutes for questions, but also I'm going to get you back. I'm going to get people to submit questions, and we'll get you back for another Zoom and answer more questions.
Yeah. I'm sorry, did I do too much? Because
No.
I actually crammed three talks in together.
And it was my fault.
Sorry.
I asked him to do that because I know mind would be officially blown, and that it would take a while to like sink in to think of questions even.
Anyhow, look, this is a crazy, interesting time, but let me say it's a crazy, dangerous time as well.
Yeah.
Really dangerous time. For higher ed, it's phenomenally dangerous, I think. I could talk about that. But it's really interesting, and we've got to take control of it.
And I've got, we've got this recorded, and we'll put the PowerPoint up maybe on the site. And I've got literally every single paper that Mary and Bill have ever written around this, and not in 3 million words.
By the way, this particular version of the software was launched at 4 o'clock this morning with my 75 students who are working in there now. You saw some of an older version, but the more complete version.
I just have to tell them, Bill, that, he was up till 1 o'clock getting his keynote speaker at this conference he's at Monash into the apartments, and your colleague. But then he was up at 4 o'clock to 6 o'clock doing a lecture with 75 students. So, we need to feed him soon. So we need to clap them. Yeah. But I need to say thank you for after all that, coming here to share your brilliant knowledge with us. I think probably we'll take like a couple of questions. Okay.
And I've got to repeat them because the people online. So you say the question, I'll repeat them.
So thank you for that talk. So very new to some of these ideas, and seeing it presented like that was, a very good beginning. I guess my questions are a little bit around the evidence base that learning is happening, which I imagine you are engaged with, which isn't the focus sort of here in a way. And secondly, the efficiency, right? I mean, of what we're trying to get the student to learn and how to do that kind of as efficiently as possible.
Right, okay.
Because you saw you could spend 40 hours just going through the material it gave you back and making refinement, and to what end, I guess?
I'll start with the last question first. There's a lot of stuff on a Twitter feed, a lot of stuff on a Facebook feed, and we've learned to kind of skim things, and we've got little things like summarize that for me in 30 words. So there are all sorts of ways, expand this for me. So we've got tools there where that's a lot of stuff, but so that's one efficiency question, which is learning how to operate in these spaces in a way which is effective and efficient, given the fact that they're voluble, right? The other thing is the efficiency issue from the point of view of teachers. My view is, one of the soul destroying things was marking 100 essays, which are all the same. That's all over because this can do it much better. I could not give that much feedback that effectively on any of my students' work, right? That's just, and my argument is this is doctoral students, and if I go backwards, well, that has to apply to everybody else as well. So, but what there is the new skill for me as a teacher to build the knowledge base, which is when you put the knowledge base in, it vectorizes, it turns it into tokens. And to build the rubric agents. So there are two or three things you've got to do, which that doesn't require computing science skills, by the way, to do that. So then you become much more efficient as a teacher. So there's a big efficiency issue there. So that's your second question. Your first one, remind me, what was the?
About evidence that it's actually.
Evidence, okay, evidence. Okay, so the question, again, to repeat the folks there, is learning actually happening? The way we have evidence now is you get to the end of the semester, you hand in an essay, and someone looks at it quickly and it's a B+. Or we do an item-based test, which is pretty flawed. What kind of evidence is that? Well, the evidence we have here is every single keystroke, and it's within a marked up interpretive framework where we know proofreading is low level. That's one of the options. You know, planning something out when you copy the plan, we can see that you've actually just taken the ideas from the AI, you haven't done it yourself. So via what we call, or what's called contextual AI, we have this unbelievably granular version of every single keystroke, every single movement, every single action you do. And the computer side of it is to interpret that, to build simple visualizations, to build simple overviews of that. So the answer is there's the potential here for much more powerful evidence than there ever was before, but it's also evidence which goes to the learner. No evidence to the teacher that doesn't also go to the learner. So they can actually have a feedback on what they're doing. So, you know, one of the exciting things is this, you know, this question of evidence, where our historic forms of evidence, which is summative assessment of one kind or another, are out of business. They're just, because the answer is what you're doing is you're assessing everything all the time, and you have every single micro movement that's made, and you need to build over that interpretive frameworks which understand the meaning of those micro movements. It also means the distinction between formative and summative goes, because everything's formative. Don't ever have summative ever again. And also, by the way, assessment almost disappears because all you're doing is the work, and all you're getting is feedback. And assessment is just a retrospective view of the work you've done. So there's assessment there, but so those things are all kind of exciting. Yes.
Thank you very much, Therese Hoffenbeck. I have to admit, I agree with Baramiko still. I'm the director of the Assessment Evaluation Research Center here. My question for you is, I'm really fascinated. I'm going to read some of the papers which I haven't read. But one of the things which I'm very fascinated about is like your context US, because we have been following what's happening. And yesterday in UK, Ofsted came out with guidance of how to use AI in schools, because 50% of the UK teachers are already using it. And
50% are admitting to using it.
to use it, yeah, that's correct. And also, like in 2023, we had the Department of Education in the US giving guidelines about the leadership, how to use AI. But what happened now in the States and the US? We are wondering like what is happening there. And my key question is, moving forward, what do you think will happen in US? Who's going to guide teachers? Because teachers do not have time to read your articles or other people's articles in US and England and Australia now. There's actually like a practical question around what do we do? How is the teachers with the gap in assessment literacy going?
The question, to paraphrase again for the people online, is where's the guidance coming from? Well, nobody got any guidance about using ChatGPT, and they're all using it. So I think it's an era of post-guidance, you know, and what we're doing is we're just simply building examples of how to do things, which are trying to imagine what the future would be like, right? Imagine what kind of learning might be possible in these environments.
Take the final question.
I just want you to weigh into the crazy debates of academic literacy that are happening, academic integrity that are happening in Australia right now. So the debates around academic integrity and AI literacies are stuck in binaries, and these binaries are not moving us anywhere. And so I'm just interested in your take.
Right. So first thing is, you must be using this stuff all along because it's so damn powerful, right?
Is that one lane is none and one lane is all, and it's going to screw us over.
Yep. So what, you know, the reason why we're working on this technical solution, so as I said, we've been lucky to have a pile of funding to do it. And we're also lucky because we've had people who've been working with us long-term on projects who just immediately this happened, they just got straight into it. You know, the solution is to build environments where the AI use is transparent. So, you know, I always say the obverse of surveillance is transparency, right? So what we've built is a surveillance system, but it's also a system of transparency. So one of the ideas here is, let's say the teacher doesn't want to log in or use any of this system. What happens is the student can export their work with a complete record of the AI, which they can hand in and print it out and hand it in if they want to. So the thing is being transparent about it. And, you know, our kind of argument also is that if at the end of the day, you can say this is 50% AI thinking and 50% your thinking by a whole lot of kind of algorithmic stuff, which kind of estimates what that is, the work will be twice as good, and you will have learned a pile of stuff that you wouldn't have otherwise learned, right? So that's kind of what our argument is. I was going to say one last thing too, which is, can I just say one last thing?
Of course.
Which is, this stuff is also devastating, and it's going to be devastating for higher ed. The reason why is that all the jobs, higher ed is designed for the knowledge economy, and software, forget about it. Lawyers, forget about it. Doctors, forget about it, because we'll need nurses, but not doctors. So one of the things is that our labor-intensive knowledge economy is going to be very much supplanted by this. Unless we get on top of it, it's a real problem. And you know, there's going to be, you know, it's also dangerous times. So, you know, we want to be on top of this to understand in what ways it's dangerous times. I don't think it's going to be devastating for K-12 for the simple reason that someone's going to look after the kids. Duty of care. It'll be devastating for higher ed. It'll be devastating for doctors, but not for nurses. So, you know, there's going to be a huge labour market shift where a lot of the high-end stuff we did in higher ed, there's going to be much less demand for it. So, for example, this work here, the key AI stuff that's in here is done by an absolutely brilliant developer who we have, who's worked with us on this for 10 years now. So now he is now 10 developers because he's using multiple AIs to write the code. But it's a really, he's worked in software development for 20, 30 years. He knows what he's doing, and it's just increased his productivity tenfold. So we're going to need very few high-level lawyers, very few high-level doctors, very few, and they're going to be people who are AI literate, right? But the problem is the 9 people are not going to get jobs now in these labor-intensive knowledge economy things, which is the bread and butter of higher ed. So, you know, it's both interesting and exciting, but if we lived in a nice world, which we don't, we'd say that, okay, we all work 1 day a week, and we'll go, you know, hunting in the morning and, you know, the crow, and fishing in the afternoon, or blah, blah, blah. It's not going to be like that. The 9 people are going to be out of work unless we do something socially about that. So I don't want to leave without saying, you know, this is both exciting and dangerous as well.
But
Bill, we actually do have some questions online. Is it possible?
I don't mind going for another 5 minutes.
yeah, but I just wanted to say, in addition to that, I've been at a couple of seminars with you and Mary recently, and one of the things that got me talking to you recently was about this idea here at the University of Melbourne about this secure environment. What does that mean? And what Mary was saying in the seminar was that this is secure. It's a bounded LLM.
Right.
And secondly, she was saying about how it changes the role of the teacher,
Yep,
because managing those rubrics. So I just wanted to emphasize that within, because we're here at the University of Melbourne, we're apparently in 2027, we're going to be having these discussions about what is secure, and we've got it here.
Yeah.
And it doesn't mean invigilated exams. It means this. And as you said, Bill, it means that that, you know, the roles change, but anyone who's not using AI is crazy.
But also, that security point is pretty important. We do call back into the foundation LLM, but by the time we do, it's so garbled, there's no identities there. But we build up a very strong identity about you as the learner, and you've got to trust that. And if you don't trust that, well, look, it is a good option to go and grow vegetables, by the way. But so if you don't trust that, I'm afraid these systems, remember that early slide, these are all learning systems, and this is powerful because it learns about you. But what we've done is we have kind of, it's not OpenAI. If you use OpenAI as your selection, they don't get to know anything about you, because what we send is just garbled high-level stuff.
I was just going to ask Amy for, can we just
one question? Let's have 1 or 2 questions from there.
Okay, so one question is, I wonder how, by restricting expert knowledge in English to what we choose, how might we allow students to bring in their knowledge across languages? Also, in Aurea, did the meaning change based on what had been said in the original student's work and what had been written? I thought LLMs draw on tokens and cannot make meaning as it's originally meant by the authors, yourselves and your students. How do the tokens work across languages?
Right. So that's a great question, a difficult one. What you've heard from me is the theory of latent semantics. You know, how must they, given that they can do this thing, how must they be working? And as I say, the Aurea work is not just a translation, it rethinks the problem in Aurea and restates it. Yeah, what can I say other than, you know, that this is it's kind of surprising. These machines which are incapable of meaning anything end up meaning stuff to us as humans, because, you know, that if the way they operate with language, essentially. So yeah. One more question from online.
Yeah, one more question was, is this open, the tool, CyberScholar, is it open for anyone to explore using, and does it store information uploaded? So if a teacher uploaded the student's task, does the AI store it and then use it?
Stores it all, and it won't work unless it does. So if you don't want to be in storage, as I say, I've got chickens and I've got a vegetable garden, and that's a nice option. But unfortunately, these systems are premised on storage, right? That's what they're premised on. So it stores it all, but the only thing is we don't hand it over to Sam Altman or Elon Musk, right?
Yeah.
That's the only difference. So what you've got to do is they're based on trust, and you've got to trust us. And if you trust us, as I say, I love the vegetable option.
Yeah.
And is it open for anyone to explore using, or is it a purchased product?
It's not a purchase product. So in terms of the university owns me, so the university owns the IP, but also we have a not-for-profit called Common Ground, which is based in the University Research Park. You know, eventually what we have to do is make this thing pay for itself, because it does, you know, the people who work on it, they eat and they have mortgages. So our model is going to be kind of a not-for-profit, self-sustaining model. It's not available at the moment, but if you as a researcher wanted to, I can tell you how to access it. It's not visible on the web, but I can tell you how to get to it. We will make it visible sometime soon. As I say, a lot of what you saw, or a third of what you saw today, was released today or yesterday, which is why I was a bit awkward getting through some parts of it. Yes, but it will be. And if you as a researcher would like to use it, I can tell you how to get to it.
Right. Thank you. I'm also going to just share my screen for a second, which has got our QR code for providing feedback on the session. If you can let me know.
Well, I just want to say thank you so much to Bill in your busy schedule of being here in Melbourne for 6 short days. Thank you so much for enriching enlightening us and expanding our minds about this, because there's just so much to know. And we're being very much pushed in a way with the word like secure to like close it down. And that's the sort of the vibes we're getting. So I just feel invigorated that you're saying open it up, but not just sort of, you know, without constraints. There are, you know, pedagogical decisions to be made here, which you and Mary and your amazing teams have made, and given us a glimpse of what is possible. So I just want to say thank you very much, and I'd like you to join me. So thank you for coming, everybody. We had to change the room and everything, and I can't tell you how much stress it caused Amy and I want to acknowledge Amy's work. Amy's our coordinator of seminars in the Global Childhoods Research Hub, and we just thank you for coming and making this such a valuable experience. And Amy, I think you're going to stop everything now, aren't you?
I am. Yeah.
Yeah, you got the power, Amy. You got the power.
Got the power. Yeah.
Yeah.
Thanks, everybody.